So today we're going to take our equation solving into the real world. We're going to apply our equation solving to real world problems. And today we're going to do, a little bit more with the break even, which I still think is the most important. We'll do some geometry perimeter, and we'll also do consecutive integers. Consecutive integers is the least important in terms of real world. However, sometimes they can sneak onto standardized tests, so I figured I would just introduce them. So we're going to remember that when we are working with an application or a real world problem, the first thing you're going to do is define your unknown. If you read the question, it usually lets you know what that variable is going to be, what's missing. The second, and don't forget to put your units in there. The second thing is you're going to write an equation with all the numbers involved, relating the variable that you've defined to all those other quantities. You're going to then solve the equation using good equation solving steps. You're going to check your solution, and then you're really going to make sure that you're answering the question asked. That involves putting your units in, and it also seriously makes sure in some of the cases, especially in our next video, that you're answering the correct question. So we had done the dancing hot dog problem, hopefully in class. So now I'm going to add another one, which is a banking question. So imagine that you have $22 in the bank today and you start depositing $1.50 each week. At the same time, your cousin, who is like, I don't know, Mr. or Ms. Moneybags, has $254, but is withdrawing $13. Withdrawing means taking out. So starts with a lot more than you, but is taking more out each week. And we want to know, when will the accounts have the same balance? Now you might say, well, this is easy to do with guess and check. And I would agree, but all we have to do is really make these numbers a lot bigger, and that possibility would go out. So I'm going to keep the numbers small, just so, mathematically speaking, it's not overwhelming. But just realize we need to do those 5 steps in order to solve it rather than guess and check. So the first thing I do is I read, when will your accounts have the same balance? When is time? And in this case, I go looking, it's weeks, see? So how many weeks is it going to take before you have the same amount of money? So you're going to assign a variable. It doesn't matter which one, as long as you define it. And weeks has to be in there, not just time. Now I need to kind of think about, what is my equation? So basically there's a you and there's your cousin, and we want them to equal. So we have to take into it and write an expression of what you're doing, and we have to take what your cousin's doing, and we have to set them equal. So you're starting with a constant of 22, but then the $1.50 per week, that is changing, that's varying, that's what's going to get attached to the variable. Your cousin's starting with a constant of 254, and he's taking out 13 per week. That's what's changing for him. That's what's varying. Think about and see if you can come up with that equation. Okay, so do you agree with mine? So you're on the left, your cousin's on the right. And now this is just a variable on both sides equation. So I'm going to start by gathering the variable on the same side. I added the 13W so that I would have a positive coefficient. Remember, there is another way to do it, which would be to subtract 1.5W. As long as you show your steps and get the same answer, that is A-okay. So now I've got a 2-step equation. I'm going to subtract the 22, and then I'm going to divide by the 14.5, and it comes out to 16. I have contrived this one to work to this whole number. In the real world, it's quite likely you could have come up with something like 14.6, and you'd have to say somewhere in the 14th week. But just realize they don't always come out to, perfectly nice numbers. So now I have defined, I've written, I've solved. Now I'm going to check my answer by putting it back in the original for the 2 W's. And I'm going to do my order of operations on both sides. So I'm going to multiply. Be careful not to go left to right, just not thinking. So we're going to multiply first on both sides, and then do the addition on the left, the subtraction on the right, and hope we've got the same number, and we do. So now I need to answer the question, when will your accounts have the same balance? It's going to be 16, and right here we can see weeks. So our answer is 16 weeks. There's another interesting piece of information here where if I had said, and how much would they have at that time, you don't have to work too hard because it's right here. we put the 16 in and calculated your balance on the left and calculated your cousin's balance on the right. $46 would be, if I had asked that question, what the balance would be at that point. But again, you want to make sure you're answering that question. In this question, you didn't need the $46. I'm just putting that there so I could remember to tell you that, to be perfectly honest. So that is a break-even problem. And it is one of, I think, the most important problems in the real world, to kind of figure out when companies go into profit. And we are going to do that same problem a different way a few units down the road. So we will revisit some of these problems in a different way. So the next one's going to be a geometry perimeter problem. There is a common mistake in here that I will caution you against, but remember that a perimeter of any shape, any two-dimensional shape, is the distance around. Basically, you're trying to put a fence around the entire shape. So in this particular case, the width of the rectangle is 3 less than its length. Because we are only working with one equation and one unknown, we have to write one of the variables in terms of the other one. So the width, we're going to change the width's name. So this could be W and this could be L, but we can't have two variables. So the width is, so W equals 3 less than the length. Length, take away 3. You should not have 3 minus L. Think about it. What would 3 be? What would 3 less than 20 be? You wouldn't take 3 minus 20, right? So when you see this less than, the minus goes behind the variable. So instead of putting W as a second variable, we're going to use L minus 3 because that equals W. Now to find the perimeter, we are going to remember that for a perimeter, make sure you realize you have to go all around the shape. I did define too, really, you don't need this one because we didn't use it, but I'm just letting you know that if you had put a W here and then changed it, you would have had to define it. So to be perfectly honest, this guy could not, you would be okay not to have him since I didn't use him. Now the formula for a perimeter is 2 lengths plus 2 widths. And I know you all know that on a rectangle, but somebody every single year will forget the 2's and just put length plus width. And basically think about putting like a fence around your yard so your dog doesn't get out. You've left 2 pieces off. If you do that, the dog's just going to run out. So now we're going to replace this formula, with what we know. So the perimeter is 26. So that's going to take the spot of the P. 2 lengths plus 2. Now that W is going to become the length minus the minus 3. So there is our perimeter equation. And this is not a variable on both sides, but we do have distributive property in like terms. So we're going to solve that and check this. Again, the number one mistake is to not have the 2's in there. So here's my equation. So I'm going to do the distributive property. Don't forget to distribute to the second piece. Don't forget that a positive times a negative is a negative. I'm going to combine my like terms, 2-step equation, add 6, divide by 4, and I get a length of 8. And the question is 8 what? So, if we go back, this is where defining your variables is helpful. Right there, it's inches. I don't even have to look any further. So hang on a second. Let's get to the answer in a second. Let's check it by putting the 8 back into those 2 L spots right there. I'm absolutely okay if you start at the second. You don't have to write this top one in your check. I'm not sure if you had to last year. So just know I'm okay if you start right here. Remember, we're not going to do distributive property. We're going to do PEMDAS, 8 minus 3 inside the parentheses. Please be careful to multiply before you add. And then we are going to be happy people. So what was the question here? Let's go back and just look. What are the dimensions? So if you kind of stopped here and just left this length, you're not getting both dimensions. To get both dimensions, we're going to have obviously the length of 8 inches, but remember that the width was 3 less, so you can put both of them. So there's an example to make sure you go back and look at the question, answer the question. That's why there's this step 5. Put the units in, make sure you're answering the right question. Okay, so this is a chance for you to try one of these. So what I would like you to do is pause the video and do this perimeter problem after we read through it together. So Louise has 96 feet of fence that she will use to enclose a rectangular garden with a length that is 3 feet longer than twice its width. What are the dimensions of Louise's garden? How about if you pause the video, define your variable, write your equation, solve it using good steps, check it, and make sure you answer the question. And when you're ready to come back, unpause the video. I'll be waiting for you. All right, so let's see how you did. Now remember, as I go on, that's a stray box. Remember as we go that your variable could be different than mine, right? So I'm going to let W be the width and the units are feet. That's going to help me answer the question at the end without having to go look back in the verbiage as to what's going on. So the perimeter, 96, is going to equal 2 lengths plus 2 widths. Now remember that the length is 3 feet more than twice the width. So that is a length, 2 of them. So make sure you have this length written correctly in terms of the width, and make sure you got the 2's in there. Now it is distributive property, combine like terms, subtract the 6, divide by the 6, and you get W equals 15. One good news about a lot of these real-world applications is the negatives. I don't know if you noticed, the negatives aren't there because you're not going to talk about negative feet. You're not going to talk about negative dollars and weeks. And, I guess in business you can talk about loss and stuff. But pretty much when you go into a lot of applications, the negatives aren't there as much. Okay, so now we need to check him. So the 15 is going to go into the 2 W spots. Oh, forgot. Sorry, that's my picture. Forgot all about that. Oops. So there is the check. Now I'm going to do what's in the parentheses. So I'm going to multiply the 2 times the 15. And then I'm going to add the 3. Now I'm going to take 2 times 33 and add it. And sure enough, my check works to 96 equals 96, which was the perimeter. No surprise there. What's the question? What are the dimensions? Well, we know that the width is 15 feet. And then if we kind of put the 15 in there and do the math, which is kind of what we did right in here, right? So 2 times 15 is 30 plus 3 is 33. And those would be our 2 dimensions. So the width would be 15 and the length would be 33 feet. So that is a geometry perimeter problem. The last one is this consecutive integer problem, which again, you're going to sit there and say, well, I could guess and check this one. And I get that. But if I make the number really horrible, it's a lot harder to guess and check. So I'm just trying to keep the numbers reasonable to not make the math be the problem. So basically here, consecutive means in order. So the numbers 3, 4, 5, 6 are consecutive. If we were talking about consecutive evens, it would be like 10, 12, 14, 16. If we were talking about consecutive odds, it'd be like 31, 33, 35, So it doesn't have to start at 1. It's, somewhere there are going to be 3 numbers or 4 numbers or however many that are going to add to a total, and you have to find them. So this one is the sum of 3 consecutive integers is 72. Find the integers. So we're going to define the variable as to be the first one. So in this case, the first integer. If it was even, I would say first even. If it was odd, I would say first odd. And now think about it. To write an equation for 3, you would have the first guy plus the second guy plus the third guy has to equal 72. So you have 3 numbers. Now the first one is n. But the second one has to be 1 more. And the third one would be 2 more than the n. Are you with me? So this would be your first consecutive. This would be your second consecutive integer. And this would be your third. Now remember, we're talking about integers, guys. You should not get a decimal or a fraction answer. They should come out to positive and or negative of the whole numbers. So now what's my equation? First plus second plus third has to equal 72. It's kind of a crazy looking equation. And oh, by the way, the parentheses are not necessary in here. I put them in just so you could see first, second, and third. But there is the coefficient of this parenthesis is a 1. So you really don't need the parentheses. There's no distributive property. So now it would just be, solve and check. We just got to grab the like terms and put those guys together. And we pretty quickly will end up with a 2-step equation. We're going to subtract 3 from both sides, divide by 3. And here is where you should not get a decimal or fraction. Otherwise, something's wrong because it should be integers. So 23. Let's put it back in. Now I'm going to put it back in and do the legitimate check where, you have to put it back in the original. But on these consecutive integer ones, which to be honest, these problems are kind of, for lack of a better word, stupid. I'm okay if you just say, well, I got to have 23 plus 24 plus 25. I mean, that's basically what you're going to be doing here. So if you just do the check from here and actually make sure that it does add up to 72, I'm okay with that for this check. So now to answer the question, don't just leave this hanging out there. Remember, we needed the 3 consecutive integers. So your answer would be 23, 24, and 25. So here's just another one. It doesn't matter if it's odd or even. It's kind of the same kind of thing we're doing here. And again, I picked a really silly number. You could guess and check this in a heartbeat. But, so the first odd integer I'm going to name as n. I need 3 of them that add to 15. So no longer is this going to be n plus 1. Like imagine that this number was 3. To get to the next odd, you have to jump over the even, so it's a plus 2. And if you started with the first odd here to get to the third one, let's say this was 5, add 2, it would be 7. The next one would be 9. You'd have to add 4. So you're jumping over the basically evens in this case. Now, if your first one was even and you do want to define, you want this word odd or even in your definition. But even if this was even, it would be the same thing because let's say you were looking for evens to add up to a different number and this was 6. To get to 8, you have to add 2. So whether it's even or odd, you're still going to be jumping over the other one. So here are my 3. I'm going to total them up to the silly number of 15. Parentheses not necessary. I'm going to join up my, just put this up here, sorry. I'm going to join up my like terms. There's 3 n's and 2 plus 4 is 6. It's a 2-step equation. And here, you do not want to get a decimal. I'll have somebody give me a decimal or fraction at some point. Something's wrong. You've done something wrong. And now I want 3. Now be careful. My answer isn't going to be 3, 4, and 5. It's odd. So it's going to be 3 and 5 and 7. So in the check, you're going to notice this check, I just kind of went right there, but just don't write it and not check it. Make sure they actually do add to the total. So that's what a consecutive odd, or to be honest, consecutive even would look like. Of the 3 word problems we've done today, by far the break even is the most important. It is something you will face some point in your life. The perimeter problem is a good step up into geometry, which is your course next year, and the consecutive integers are kind of to be perfectly honest. And the only reason I wanted to put them out there is just in case they slip into an SAT or a standardized test, you just have sort of an easy way to combat them rather than come at them with guess and check. So guys, we're starting to apply our equation solving techniques. Please, as you start to practice, remember to always do the 5 steps. Define your variable, write an equation, solve the equation showing proper steps, check your answer, and always make sure to answer the question asked. I hope you have a great day. I'll see you soon.